Thank you for taking interest in my research focused on dual-mode hairpin resonator using FR-4 material. I am Rena and I worked alongside Dr. Shantanu Chakraborty from Valdosta State University. Starting off, a hairpin resonator is a U-shaped resonator that allows a selected range of frequencies to pass and impedes other frequencies. This is used for suppression of resonance in microwave communications. To keep the resonator compact, we used microstrip structure. The ground layer of a resonator is copper. Next is the dielectric layer, which is PCB or FR-4 board, which has a dielectric constant of 4.4. The transmission lines are made using copper tape with thickness 1.5 mm. These materials were selected because of their low cost and commercial availability. A via is placed at the center of the U shape to connect the microstrip to the ground plane in order to separate the even and odd mode resonant frequencies a dual mode resonator has. The via was initially constructed using regular lead-free solder. Using the solder resulted in high impedance, even though it provided negligible resistance at DC. The blob of solder offered high inductance at microwave frequencies due to inductive behavior. We bypassed this problem by using a thin gauge wire to create the via. Using a vector network analyzer, the frequency response of the resonator was tested from 1 MHz to 2.5 GHz. The gathered data was then compared and simulated for S21 to show the transmission signal through the resonator. Comparing our resonator to the model created using the free EM simulator Sonnet Lite, they both have a pair of resonances at close to the same location. For the experimental resonator, there is a peak at 0.82 GHz, followed by a second peak at 1.04 GHz. The model resonator has a peak at 0.95 GHz and a second peak at 1.04 GHz. These two peaks show that our experimental resonator shares similarities with the model. However, the harmonics of these resonances again appear around 1.59 GHz and 1.95 GHz respectively for our experimental resonator, which is about double the previous frequencies. In the future, our goal will be to lower the impedance of the via connecting the ground plane to the transmission line. To improve the filter behavior, we plan to try different types of conducting materials like colloidal adhesives and silver to create good RF microwave connection between the transmission lines and the ground plane. If you have any questions, feel free to leave a comment below. This video was created for the 2020 Georgia Undergraduate Research Conference.